In this addendum video, I want to go into a little bit more detail about how Babylonians would have calculated the area of a right-angled triangle. However, before we do that, let's first consider the problem of not having a 0 in their base 60 arithmetic. To see how this can lead to trouble, let's consider some examples. The easiest example is the single unit 1. 1 is the same in base 10 and base 60, and it is represented as a single downward stroke. Now let's consider 60. This would be written as 1, 0 in base 60, but because we don't have a 0 in cuneiform, this would be simply written as 1, or a single downward stroke. Thus 1 and 60 would be represented as the same cuneiform symbol. Hopefully you can see that this could get very confusing. Another skill we need to have is multiplication in base 60. Multiplication works exactly the same way as it normally would, but we have to be more careful when our numbers go over 60. For example, 5 times 5 is 25. Since this is less than 60, the Babylonians would write it, just as we would, as 2 tens and 5 units. However, when our number is over 60, we have to be a bit more careful. Suppose we did 30 times 30. This would be 900 for us, but using the analogy of time, we can turn this number into base 60 by saying, how many minutes are there in 900 seconds? Well, it turns out there are 15 minutes, thus 900 seconds could be written as 15 times 60, or 15-0, which to a Babylonian would be 1 10 and 5 units. Again, we see the huge scope for confusion, as without a 0, the numbers 900 and 15 look exactly the same to Babylonians. Going back to the clay tablet, we've transcribed all the elements we can see. Specifically, there is a right-angled triangle, the height and width in cuneiform, and the answer that has some of its digits missing. Finally, we convert these cuneiform numbers into Roman numerals, and finally convert them into base 10. If you want to see more about where these numbers come from, please see the original video. But what we want to do is reproduce the digits that have been lost to history, so we have to follow the area calculation for the triangle. To calculate the area of a triangle, we use the simple formula that the area is height times width divided by 2. This formula comes from the fact that if we double the triangle and add it to itself, then we get a rectangle, whose area is just height times width. Thus the area of the triangle must be half of this. In order to calculate this area, we would expect our Babylonian mathematician to do long-form multiplication. This would involve doing the calculation by parts. Thus instead of doing 345 multiplied by 15230 all in one go, we would separate it out and do 345 times 30, which is 15230, and next they would do 345 times 20, which is 730. The rest of the calculation follows exactly the same, but once again this is base 60, not base 10, so be very careful with your calculations. Once all the parts of the multiplication were done, this can be all added up to produce the correct answer for the height times the width, which is 7, 0, 1, 52, 30. Dividing this answer by 2, we get the correct answer for the area of the triangle. Since we don't have a 0, suppose we make an error in the last value of the calculation, and instead of considering the number as 34500, we consider it to be 30450, with the rest of the calculation the same as the before. Adding the error together with the correct values, we generate a new solution, which then divided by 2 provides the incorrect area of 3084845. Incredibly, these digits match those seen on the clay, and so we're able to reproduce all the missing numbers. Going back to the clay tablet, we can insert the new digits that are missing and convert them to their cuneiform counterparts, and thus we're able to predict an incorrect answer that was lost nearly 4,000 years ago.